Guys and girls, it's Noah time!
So today, your lesson is going to be on graphing logs. Now, a lot of you know what log is. Okay, so log exponents to go hand in hand. But what does a log graph look like? Question is, what does a log graph look like?
Is it just a big tree?
No. I'm going to show you what it looks like. What does a log graph look like? Now, to do this what we can do is we can just play around with our calculator and just get a visual idea. If you have a graphing calculator, now's a good time to pull this out and we're going to see what a log graph looks like. So let's grab your graphing calculator out. If you have your TI-83. Actually, you just look up here, guys. I'm going to show you what it looks like. I'm going to input this formula, and you're going to see what it looks like. Y equals to clear log. I'll make it simple for now. Log x. Nothing too complicated. And I'm going to just hit graph. Hopefully this works. And look at that. There's your log graph. It's a very simple line. It goes from here all the way up. So let's just draw this right now. Y equals to log x. And I'm going to draw a rough sketch what it looks like. Based on my calculation that we just saw, your graph looks something like this. It starts from down here and goes up. And it kind of curves. Okay. That's your log graph. Now, this log graph is dependent on two things. One, there's the b value right there. I'm going to write a few things star. The shape of a log graph is dependent on the b value. It's dependent on the b value. There's actually a log graph has two forms. I'm going to show you both forms right now. If b is greater than 1, your graph will look like this. So I'm just going to draw it nicely. It starts from down, goes up, and it curves. That's all this is. It starts from down, goes up, and it curves. This is case 1. 2. If b is between 0 and 1, what happens is this. Your graph actually starts up here and goes down. It kind of flips it. Sorry, wait. Yep. Give me a second. So guys, really, your shape of the graph is dependent on one thing. What is the b value? Okay, that's all it's really dependent on. If your b is larger than 1, you start from down and then you go up. If b is between 0 and 1, you start from up and goes all the way down. Very nice. Keep it simple. Now, I'm going to show you steps to graphing. I call this my steps to success. Steps to success. Double C, double S, and you always succeed. 1. Find domain. When you graph a log, this is the steps you're going to follow. If you follow every step, you will get a perfect graph every single time. 2. Find asymptote. Asymptote.
There's only one S, isn't it?
Yeah. Was it a P or without a P? Asymptote. Okay. My asymptote has 2 S. Bad joke. My lame joke of the day. Here we go. 3. Find x and y-intercept. And I'll have to, number 3 is actually the hard step. A lot of people can't do. I'm going to show you how to do that in detail. Finally, step 4. Go with the flow. Go with the flow.
For finding the x and y intercepts, is it just like finding intercepts in grade 11? Like
Yep, same concept.
X to 0?
Yep. I'm going to give you a question. It looks complicated, but really, I'm going to show you how to do this step by step. Now, let's start with the domain first. Y, I'm going to start easy, equals to log 2x minus 1. Let's say I have an equation that looks like this. And I'm going to make it a bit more challenging for you. Minus 1. You cannot say minus 1 and minus 1 becomes minus 2, because this is in a nice bracket. Guys, gals, we're going to do step by step. Take a minute, work with the person beside you. I'm going to pause it, and you're going to find it. So guys, gals, to find the domain, remember, the only thing I care about when you do domain of log is just that stuff. Set that stuff to be greater than 0. 2x minus 1 is greater than 0. X is greater than 1/2. Done. Now, let's draw a little sketch of my grid right now. I'm going to show you what domain is. Guess where 1/2 is? I'm going to say 1/2 is right about here. 0.5. Just guess. The domain means that my graph has to start from here, somewhere here or greater, and it goes all the way to the right side. I cannot have it to the left. Can't be done. Okay. Step 2. Find your asymptotes. A lot of people say, what the heck is that? An asymptote is really an imaginary line that your graph never crosses. Where is the imaginary line that your log will never ever touch? 0.5. Would you agree that your asymptote is right here? Because this is the border that says you cannot cross according to my domain. So draw it in a vertical line right here. So let's write this down. Your asymptote is an imaginary line. Imaginary line that the graph can never cross. The graph can never cross. Never cross. It occurs at your domain. This is the reason why I'm so picky about your domain. It occurs at the domain. So we're going to draw this in. And we're going to write down x equals, notice I'm using the equal sign now, 1/2. That's where it is. X equals to 1/2. Done.
That's asymptote, right?
That's your asymptotes.
And domain always uses the greater than.
And domain is an inequality. Asymptote is an equal sign. It's where your domain is, basically. Guys, gals, step 2. Done. Hey, this is pretty simple. Step 3. X. Let's start with the x-intercept. In grade 11, back in the days, remember what your grade 11 teacher taught you. If it's an x-intercept, we gotta let y be something. Y has to equal to 0. Back in grade 11. So we're gonna write down my equation again. Y equals to log, open brackets, 2x minus 1, end bracket minus 1. We're going to let y be 0, okay, because that's what the definition of x-intercept is. 0 equals to, guys, I'm going to pause it right here, and I'm going to let you find x on your own. This is solving for x. You've been having a lot of practice with this. Watch what I'm going to do. I'm going to move this minus 1 over. I have 1 equals to log 2x minus 1. I got up to here.
Can you go exponential?
Ah, this now goes back to the hidden rule I was talking to you about. Kavir, what do you do? No idea? Monica, what do you do? Wow. Exponential form.
10 to the power
Yep. See, when you have log on one side and a lone number on the other side, you put it in exponential form. 10 to the power of 1 equals to 2x minus 1.
X is equal to 11 over 2.
And solve it from here. X equals to 11 over 2, or roughly 5.5. That's your x-intercept. We're going to do this again one more time for the y-intercept. Y-intercept. So I'm going to write my equation again. Y equals to log. Oh, we have a new student. New student. So guys, I'm going to go 2x minus 1 minus 1. If it's a y-intercept, I let x be 0. So log 2. Please do not say that's 20 minus 1. Guys, that's not 20 minus 1. That's 2 times 0 minus 1. So, what's your y-intercept? I just solve this right now. Y equals to, which is error. Because you can't log a negative number, which means there's no y-intercept. No y-intercept whatsoever. Done. So let's plot what I have right now. I have 5.5 as my x-intercept. So guess where 5.5 is? I'm going to say 5.5 may be around there. Look at the base right now. The base is 10. You know the shape of your graph. Your graph is going to look something like that. Because if the base is 10, starts from down. I want you to draw in your graph right now. Okay, that's all we're going to do. See, I know it's going to start somewhere here, close to this asymptote, and it's going to go up, 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 and I just go with the flow. And I go up, 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 and up, 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 and slowly curves, something like that. Okay. And that's all there is to doing log graph. Very simple. It's dependent on your base. That base is key. The shape of it.
So that blue dot is 5.5?
Yep, that blue dot's 5.5. Again, because I'm playing the guessing game. Okay, I'm just drawing a nice quick sketch because I just want to see quickly what the graph looks like. Guys, I'm going to give you a question. You're going to try this on your own without my help. And I'm going to walk around, give you a few minutes to try this out. Y. That's why. Where does it cross the y-axis?
It doesn't.
It doesn't. That's why there's no. Y equals to, let's say this one, log, open bracket, 2x minus 3, end brackets, minus 2. I'm going to ask you graph using the 4 steps. When I ask you to graph, it means I'm giving you a lot of target marks for this one. Graph using the 4 steps. You got to show me all that work in detail. This is why I said log graphing is probably the easiest thing there is for you. I'm going to pause it. Give you about 4 or 5 minutes. Sorry, I'm going to change the minus 3 to plus 3. There's a reason why I want to do that. First thing, I'm going to work with my domain. See, domain, really, I just focus on that stuff. Nothing else matters when it comes to log. So I go 2x plus 3 greater than 0. Vikram, what's your domain? X is? Negative 3 over 2 is correct. Again, I want to visualize where everything is, so I'm going to draw a rough sketch. I'm going to guess this is going to be negative 1.5 right here. My domain is greater, so I know my graph has to go to the right. That's the reason why I visualize it. Okay. Now, I'm going to draw in my asymptotes. And Robert, where's your asymptote going to be at? X equals to, please, you got to say this. You have to say x equals to negative 3 over 2. I'm going to draw in my little asymptote right now. So this asymptote really is an imaginary line that your graph can never cross. It's like a boundary. It's like look but don't touch. Okay. 3. This is where the hard part kicks in. Your intercepts. I'm going to start with the x-intercepts. My equation is y equals to log 2x plus 3 minus 2. I'm going to let y be 0. And it's just a simple game of solving now. 2x plus 3 minus 2. 2 equals to log 2x plus 3.
10 to the power 2.
Now, log on one side, low number on the other side. All this is just using rules. Gavina, what do I do now?
You go 10 squared and 2x.
Good. See, I go 10 squared equals to 2x plus 3. And we're going to solve this. And Bana, if you solve for x, what do you get?
48.5.
48.5?
Yeah, 97.
So 48.5. Now before I go on, I'm going to play a guessing game. I'm going to say this is 48.5. I know it doesn't look like it, but I just want to see what the rough sketch is. I'm going to do the exact same thing for y-intercept. Y-intercept, no tricks. Y equals to log 2 times 0. Oh, my pen's run out. There we go. 2 times 0 plus 3 minus 2. Okay, again, no tricks. I keep it simple. I'm going to solve this. Y equals to log of 3 minus 2. Y. Ryan, what do you get for y-intercept?
Negative 1.522.
Negative 1.52. And I'm going to play the guessing game again. Somehow, my y-intercept has to be somewhere around here. To look at the shape of the graph, I look at the base. My base is 10. So guys, gals, we're going to go with the flow now. Start really close to it, but never touch. And I'm just going to draw a rough sketch. Somehow it has to go through all there. And that's it. You're done. Very easy, very simple. No tricks. Okay. I'm going to give you a supernova question for today. Good luck. Oh, whoa. Up. I know my graph can be a bit smoother, but you kind of get an idea of what this is. So guys and gals, this is called graphing logs. Very easy. Okay. Here is your supernova question for today. Good luck. Domain is one of the key things that you got to master in logs, because without the domain, everything else is incorrect. Your question is actually on domain, and I'm just going to pull it out somewhere. And you're going to show me the full work and everything. Answers means nothing without the work. I'm going to pause it, and I'm going to... Good luck. The question says find domain. Again, please circle your answers, because I will not accept it if your answer is not circled. Log 2x minus 3 of x plus 1. And let me just calculate this.
Is that base?
This is your base. That's correct. This right here is a base. This is not a base. Your question is find the domain and show me a full work. I'm more answers correct means nothing. Work correct means more to me.
Find
Okay.
domain.
Find your domain. Good luck. I'm going to pause it. Here's how it works.
Right.
A lot of you went to say, hey, so this is so easy. X plus 1 is greater than 0. So you say x is greater than negative 1. And you circle your answer, and then you're just, yes, free marks. But there's a catch to this. The reason why is, if you look at the base, there's an x in the base. So there's a rule I taught you based on Fab 4 that teaches how to do this. Using the Fab 4 rule. What Fab 4 rule is this? Think about what Fab 4 rule is this? Calculation rule. We're going to write this as log x plus 1 over what? Log 2x minus 3. So how many domains do you have for this one, Ashley? There's actually 2 domains. You did the first one already, but you forgot to do the second one right here. Because it's all based on calculation rule. This is actually a famous exam question. Learn it. Ah, you did. So you went 2x minus 3 is greater than 0, right? And that's why I said, Nisha, you're really close. 2x is greater than 3. X is greater than 3 over 2. You have 2 domains. Which one rules them all? The bottom one. This one doesn't work. Because if you have a number greater than 3 over 2, it's also greater than negative 1. But if you have a number greater than negative 1, it's not greater than 3 over 2. That's where, Robert, question. Oh, did I, you get it? Okay, let me look at it again. I probably glanced over it. But guys and gals, that's how you do it. Just remember, if you have an x in the base, there's a calculation rule. It splits it up into 2 logs. And that's what you got to be careful about. Your work. That's all there is today. Page 34. Tomorrow is the most important lesson you're going to have. Don't be away. Page 34. Numero 1, C, and D. Now, C and D is the bottom 2 graph. Take a look at page 34 right now, please, in case you're lost. C and D is the bottom 2 graphs. Not the top 2, the bottom 2. You're going to do number 3. You're going to do number 4. And I'm going to tell you what 4 you're going to do. You're going to do 4, C, D, E, F, J. You're going to do number 5, 6. And that's it. C and D are the bottom ones. That will get you to understand graphing. And I'm going to end our recording there for today.